Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra, the Math 8 edition. I'm your host, Mr. Takeda, and I'm going to teach you this is really algebra right now. This is lesson 4.4, in which we graph the linear equations that are in slope-intercept form. Hey, what do we mean by slope-intercept form? Well, we mean y equals m times x plus b. Now, previously, when we had looked at proportional relationships, we used y equals k times x. K was that constant of proportionality. Well, that's the same thing as the m in this equation, which is our slope. So we'll get more into those details in just a second. So let's go. So the first thing is we have a couple points of interest. I'm going to call them points of interest on a line that is generated from a linear equation, linear function. And the first is the x-intercept. The x-intercept is where the graph, that's the blue line, crosses the x-axis. Okay, so that's one way to think of it, but more importantly, the x-intercept is the value of x when y equals 0. So here's our y-axis. We've got, here's y is 0, y is 1, y is 2. So when y is 0, that's the x-axis. That's where when y is 0, the value of x, that's going to give us our x-intercept. Okay, the value of x when y equals 0. Up here on this graph is the y-intercept. That's where the graph crosses the y-axis. This is the y-axis. Okay. This is going to be really important. The y-intercept is going to be very important for us in this graphing lesson today. But this is the value of y when x equals 0. Okay, so again, new vocabulary, points of interest on the line. Get this in your notes, and then we're going to look at the slope-intercept form. All right, so I alluded to this on the first slide. The slope-intercept form looks like this. Y equals m times x plus b. M is the slope, so we've been doing a lot of work with slope previous to this. The y-intercept we just introduced. Think about that y-intercept. We talked about the y-intercept being the value of y when x equals 0. If x is 0 here, pretend that x is 0. Well, 0 times m would make this whole thing 0. So 0 plus b is just b. So I get b equals y. This is the value of y when x is 0. This whole term becomes a 0. Okay, so this is slope-intercept form. So make sure we get this in our notes. We'll be using this a lot in the next week or so. Now, our first task here is fairly easy. Find the slope and y-intercept of the graph of each linear equation. So they give us a linear equation like this. Now remember, we're looking for y equals m times x plus b. The slope is the number that multiplies the x. It does not include the x. Please do not make that mistake. In this case, the slope is negative 4. Before I continue, I want to rewrite this so we can think of this with the plus. I want you to think of this as y equals negative 4x plus negative 2. All right. So the slope is still negative 4. Slope is negative 4, and then the y-intercept, the plus b, is plus negative 2. The y-intercept, we use b, equals negative 2. On the second example here, this is not set to y. This does not look like y equals m times x plus b. I've got y minus 5 equals 3/2 x. So in some cases, we have to solve for y. And that means to get y by itself. So I'm going to get rid of the negative 5 by adding 5 to the left, also adding 5 to the right. So y equals 3/2 x plus 5. Now it's in slope-intercept form. And hopefully we can see that our slope equals 3/2, or y-intercept b equals 5. Okay, so these are pretty straightforward, just getting comfortable reading the slope-intercept form. Let's take a look what's next. All right, this is the big entree of our dinner tonight, I suppose. This is graphing the equation. I'll write it a little bit bigger here. Y equals negative 3x plus 3. All right, and it says to identify the x-intercept also. So let's graph this and identify the x-intercept. So this is going to take place in 3 steps here. Number 1, we are going to plot the y-intercept. Okay, so our y-intercept we know is 3, but I'm gonna write it as a point. X is 0, because remember it's the value of y when x is 0, so 0, 3, and that's going to be right here. Next, we are going to find a second point using the slope. Okay, so I know my slope is negative 3, but I want to think of this as negative 3 over positive 1, because in order to find that point, I have to think of a horizontal motion and a vertical motion. I can also think of this as positive 3 over negative 1. Because my original slope is negative, I need a negative and a positive. So I'm going to use the first one. So watch what I do here. The top number being our change in y, when this is our change in y, it's going to be some kind of vertical. And because it's negative, we're going to go down. And the bottom number being the change in x means it's going to be a horizontal motion, and it's going to go to the right because it's positive. So watch my counting here. From the y-intercept that we plotted, counting down 3, 1, 2, 3. That's this 3 here. Counting down 3, 1, 2, 3. And from here, 1 to the right. Okay, those are my 2 points. And then finally, the third thing is we're going to draw a line through the point. And for us, it's going to look like this. I hope it works. There we go. Just like that. Okay. And then so hopefully you use a ruler when you do this on paper or something. And then finally it says identify the x-intercept. Remember, the x-intercept is where the graph crosses the x-axis. So my x-intercept is 1. Now if I identify as x-intercept, I can just say 1, or you can say 1, 0, right? I can say 1, 0 either way. 1, 0. Okay, that's it. This last little slide here, this was like the crux of the lesson, because we'll be doing this a lot. We'll be practicing this class. There's other examples in this lesson. We'll be spreading this lesson out over a few days, because then we get into some word problems and things like that. But anyways, that's the graphing. All right, well, thanks a lot. I'll see you in class. Have a great rest of your day.